Plate tectonics is a complex unit that involves many other parts like volcanoes and earthquakes, but to truly understand it, we must dive into the theories, the science, and the past. It all started back in 1912 with Alfred Wegener. Alfred's hypothesis states that all continents were once a single landmass that drifted to their present locations. He also states that this would have taken place over 250 million years ago. He found evidence to confirm this, like fossils found where the continents were connected, closely matched rock formations, and climatic changes that couldn't have been all the same all the time. Wegener's hypothesis is now called continental drift. However, his theory was strongly opposed, and scientists rejected the mechanism of movement, which was that continents plowed through the ocean floor. He was easily disproved by geologic evidence, and sadly, evidence to support it was found 2 decades after his death. Pangaea was a large supercontinent on our Earth that began breaking up about 250 million years ago. The sea that surrounded this was called panthalassa. The process at which the supercontinent breaks apart over millions of years is called the supercontinent cycle. The evidence found 20 years later was enough to prove Wegener's theory of continental drift. It's called the mid-ocean ridge. A mid-ocean ridge is a long undersea mountain chain with a valley in its center. The rift expands and fills with magma, which rises from the asthenosphere and makes new seafloor. This happens as tectonic plates move apart, causing the rocks that are closer to the ridge to be younger than the others. This process is called seafloor spreading. In the late 1950s, a scientist named Harry Hess came up with a new hypothesis. He suggested that if the seafloor was moving, the continents must have been moving as well. More evidence was found in the mid-1960s through paleomagnetism, the study of magnetic properties of rocks. The evidence that was found was that magma rises up between the two sides of the rift and spread them apart. As scientists studied seafloor spreading, they kept finding puzzling magnetic properties on the ocean floor. They suggested that maybe the magnetic north that we know today wasn't always that way. Today, people have discovered rocks with opposite attraction than the Earth's normal magnitude. Scientists categorize rocks into normal polarity and reverse polarity and use these patterns to create a geomagnetic reversal timescale. There are other layers of the Earth, known as the mechanical layers. The important parts of this theory is the lithosphere and the asthenosphere in our case. The lithosphere is the solid outer layer of the Earth, consisting of the crust and some of the upper mantle. The asthenosphere is almost like a plastic layer that is made up of slowly flowing molten rock, which causes tectonic plates to float. The Earth's crust is separated into 2 groups, oceanic crust and continental crust. Tectonic plates are separated into 15 different parts. Scientists know where these are based on data from earthquakes and volcanoes. Some of the most dangerous effects of these natural disasters happen along plate boundaries. Plate boundaries are associated with geologic features and happen mostly along the edge of continents. The 3 types of plate boundaries are divergent, convergent, and transform. Divergent plate boundaries are when the boundaries move away from each other. Convergent is the opposite, when plate boundaries move towards each other. Transform is different in that the plate boundaries slide past each other horizontally. Scientists don't fully understand what force pushes on plate boundaries to move them, but they do have one theory: mantle convection. Energy and radioactivity inside the Earth's core heat the mantle material. As hotter magma rises, cooler magma flows away and replaces it, making the plates slide along it. So far, scientists have identified 2 types of movement. The ridge movement is the first type of movement, and because mid-ocean ridges are at a higher state than the rest of the ocean floor, gravity causes the ridge to push on the lithosphere that lies farther from the ridge. The slab pull is the second type of movement, meaning that the plate motion is driven by the weight of cold, dense plates sinking into the mantle at trenches. Rifting doesn't only break things apart, it adds and gains material. Most continents are made up of terranes. Terranes are pieces of lithosphere that is part of another lithosphere. There's a lot of different things that tie into plate tectonics, such as earthquakes and volcanoes. Plate tectonics have transformed Earth science so much over the past years that it's quite hard to believe it. It connects to everything. Besides, what's the point of a house if you don't have a tolerable planet to live it on?